Good evening and welcome back. I'm Robert Vaughn. I'm here with Alex Jewell and James Benke on Let's Talk Radio, RADYO, radio with a Y. And this is the DeFi Collective. And today we're going to talk about the Internet of Things. You know, I used to always hear people talk about, the Internet of Things, the Internet of Things, like what the hell is it? Well, today we're going to find out because Jim Benke is engineer. He's an inventor. He has over 25 years experience in electrical engineering, software development, factory automation. He creates new hardware and software for embedded systems, use of EDA tool suites for electronic hardware design, and simulation from board level products to complete systems design. He has experience in both analog, digital, and RF circuit design, software engineering, device driver development, coding, C, C++, C.NET, Google, Go, and Java languages. He's been doing this for a long time, and he knows a little bit about the Internet of Things. As with Alex, Alex is our front-end developer, and he also develops systems and programs and smart contracts. So we're going to do a little deep dive today into the Internet of Things. The Internet of Things can be described as a network of physical objects that are embedded with sensors, software, and other technologies for the purpose of connecting and interchanging data with other devices and systems over the Internet. You know, if two boats are going to crash, if they both have sensors, and there's a program written to make them not crash, they will both know that they're going to crash, and perhaps there can be an automatic control to maybe make one turn away. That's a pretty simple, simplistic design. And the Internet of Things devices and systems over the Internet range from ordinary household objects to sophisticated industrial tools with more than 7 billion connected devices today. Experts are expecting this number to grow to 10 billion by 2020 and 22 billion by 2025. Internet of Things is probably one of the most important technologies. We had, first we had the internet, then we had software that took the internet to a different level. Now we've got AI and sensors and RF all integrated into the Internet of Things, which you can just, do just about whatever you want to, whatever your mind can conceive. So, Alex, I'm going to flip it over to you. And why don't you lead off with a question for Jim or something, a discussion question for Jim that he can maybe address, and then we'll talk about it a little bit.
Sure. Mm-hmm. Well, I think, one thing that we really like to cover on this show is the aspect of decentralization. So, Jim, if you want to kind of talk about, from your perspective, why decentralization is an important aspect of the Internet of Things.
Let me refer back to the system that I'm designing now, the E-Plate system. That is a totally decentralized system. The E-Plate ends up being a avenue to put the IOTA, the Internet of Things, on the front of a car. Okay, and fortunately for Governor DeWine signed into law that you don't need a front plate, so it creates a vacuum that can be filled by the Internet of Things. And no, we don't expect every car out there to immediately have an E-Plate. It's not going to happen. But what we want to do is create a distributed environment where cars can talk to each other through the Internet of Things and become safer and have less accidents. So, right now we're looking at $100 billion per year in accidents that happen in just the United States. That's the total we're racking up as citizens, driving citizens. It's 100 billion a year. So if we can have a IOTA, if we can have an Internet of Things that creates enhanced driver awareness, much like the brand new Cadillacs and some of the higher end cars do. But we apply this to a broader scale of lower end vehicles that don't have that opportunity to, where you're not spending $70,000 or $80,000 on a car.
It's like
So-
everybody should have seatbelts.
Yeah, and what we're trying to do here is really a proof of concept that says this can save lives and also improve the safety record of vehicles on the road. And you do that through better awareness, awareness of the people in front of you and the people in back of you and the people on the side of you. So there's new technology coming out that allows you to do exactly that. It's called 802.11g. So, and that all ends up as a distributed system where the information is constantly being sent through an IoT hub to a database. And what you're trying to do is database all this information so that later on, you can begin to apply AI technologies to that database. And once you do that, then back through the LTE5 system, you are able to feed back critical information in real time that may help you prevent accidents.
And so to separate a little bit, this database is the database on the receiving end is centralized, or
Oh no,
so the database itself is distributed, right?
Yeah,
Which is
yeah.
okay. And
Yeah.
so the communication of data based on vehicle events, that is a decentralized communication, and that is stored in a distributed database that is also, that's the whole thing is decentralized.
It's on the ledger. It's all on the ledger.
It's all on a distributed ledger, right?
Yes.
And so this is a great example of how blockchain technology truly, like under the hood, is essentially just a database, right? It's a distributed database, a distributed ledger of information that most of the time, unless it's a private blockchain, most of the time is publicly accessible, verifiable, oftentimes encrypted, but it allows for data to be stored in a very distributed, accessible way for the systems to use in a very efficient manner.
Right.
Now, this could also be used to for enhanced control, say, of traffic patterns. The frequency to which stoplights turn red and green to facilitate a more smooth flow of traffic.
Absolutely. Yeah. I think that's down the road. I think what you want to try and start to do is your number one objective should be to save lives as much as possible.
Okay.
That should be always your number one goal is, well, how do you, you have in just the state of Ohio, okay? In just the state of Ohio, you have in excess of 300,000 accidents per year. And what you want to begin to do is develop awareness technology that says, hey, maybe if we can cut that down by 10% a year, that's a big deal, because many of those accidents end up with people getting maimed and killed and all kinds of serious medical injuries. If you've ever watched TV, you'll find a host of lawyers on TV advertising their skills to get you more money from an insurance company. Why do they do that? Because there's $100 billion pile there to take. Okay, and they want their one third of it if they can get it. Well, what we want to do is we want to make those lawyers mad because we're reducing the accident rate.
Do you foresee the APIs for this being publicly accessible so that others can build on it, right? Could there be sort of even an open source concept to this where other people can build helpful utilities, like Bob's idea of, stoplights and the flow of traffic. And, imagine if all the data Google has that it maintains in a black box and uses for its own profitability. Imagine a similar system that's actually decentralized and distributed and owned by the people who rely on it, the drivers on the road, where other people could build on top of it and build their own utilities.
Yeah.
Yeah,
For instance, I'll give you for instance, like I went to I've driven to New York. And one thing about the drive to New York, it could take you 8 hours and it could take you 16 hours coming back. Now, if I could find out what's the best time for me to drive to New York, where I can get there in the fastest amount of time, I'd kind of, organize my trip around that. Or what time can I come back? And what route should I take that I can get back in the least amount of time? I think that's useful. And that could perhaps save lives, because there would be less people trying to get through. There would be less bottlenecks. I think there'd be less frustration, maybe less road rage. And I think it would facilitate, just the system running a little smoother. Speak on that a little bit, and also talk about aircraft. I want to talk about aircraft too.
Okay, well, that already exists pretty much.
Okay.
Garmin has some very nice GPS hardware that's not cheap. I wouldn't call it low cost hardware by any means, but they do have a companion service that goes along with it that pretty much does exactly what you just outlined. It gives you best times, best routings to avoid traffic. But I mean, you're looking at about a $400, at least a $400 box plus a service, and it basically just does GPS. Where our differentiation is, we want to actually create awareness around your vehicle as much as possible, so that basically there can really be two AI systems. One is a cloud-based AI system, and then because we're using Qualcomm Snapdragon, based hardware, there can actually be an AI system within the Qualcomm hardware that does real-time, instantaneous updates right on the spot. So it probably will end up with being a dual loop AI system. One in the embedded hardware, which is very doable, and the other one in the cloud. So basically, you can look for short-term trends in the embedded hardware, and then you can look for longer-term trends in the cloud system.
That's cool.
And that is the best of both worlds, and that's what you need to shoot for, because you're trying to find needle in the haystack problems, literally. And the best way to find needle in the haystack problems was with excellent AI.
Right.
Yeah. So you're using
humans can only trace you can only trace all the branches so many times. But I think the important thing, for example, when you talk about the Garmin idea versus what this embodies, is the Garmin idea is that Garmin has a business model, right? Garmin is profiting off of that business model. It provides the end result, right? It provides you the quickest route depending on traffic and things like that. But it provides it in a way where Garmin's they're profiting off of the hardware, obviously. They're profiting off the service. And then they're profiting probably, most likely, off of what they learned from the data as well, right? I'll
guarantee they are.
And that's probably the hidden business model that a lot of people don't realize what their data is. And so when you create a model that we have the ownership over the data as the people who use it, that's a very different way of thinking about what data can accomplish and how to own your data, right? And I think that's the important, differentiator between a decentralized model for how we share data and create utility around it versus relying on centralized companies and their black boxes to provide us a service, but in return, we're allowing them to profit greatly off of it.
So, as a side, Google tracks everywhere you go. So you're not going to get anywhere from being tracked. And of course, part of that tracking is to be able to see what businesses that you are visiting. And then it allows Google to fine tune their advertising to you, which is always the goal. Is I want to narrow my marketing scope, and I want to do that through the data that you give me or I take from you. Either way.
Yeah.
Let's talk a little bit about airplane traffic.
Well, the same, this system really, really came from the E-plate system. Really came from a NASA SBIR that I wrote to allow free flight, and that's really doesn't go very well with the FAA. They want to control everything, and most governments want to control everything, But there's plenty of other opportunities, like in Africa and the Middle East and many other countries, like even Canada, where a free flight model would make a lot of sense because the radar systems aren't there. In other words, if you don't have existing radar, and this country does, it has an enormous radar base from one end to the other, then naturally you're going to want to try and use that as much as possible. But the system that I proposed was based on the ability to. I'm trying to think of a low-tech way to explain this. It's based on sending out signals, getting a readout from another airplane, and then having that information transmitted back to your airplane, and then basically you use a linked list to essentially say, I know where you are on a vector basis, and I know where I am on a vector basis, and are those two vectors going to collide? It comes down to something that simple, and it's non-radar based. So it works on the ground, it works in the air, it works anywhere, including places that don't have any radar whatsoever. So it's truly differentiated, and has a lot of potential. But the biggest problem with anything FAA related is the FAA, and it's very difficult to get through to the FAA on anything new or different.
Okay. Right. Now, this technology.
I'm sorry. Even if it works like a charm, their orientation is that they've had decades of radar use. But the problem is that for every sweep of the radar, there's exactly 1024 digital slices that you can tell where something's at. So you have exactly 1024 opportunities to digitally slice something for an air surveillance radar. And that's not enough for drones, and it's not enough for things on the ground, and it's not enough excess capacity. There's no
precision, precision of a vector, is way higher than that mesh, right?
Absolutely, yes. Yeah. I mean, you can get with even the simplest vector math, you can get it down to less than a tenth of a degree, and I don't think you can do that with an air surveillance radar.
Okay, let me ask you this now: with the advent of 5G and virtual elimination of latency, signal latency, because there is some, but I guess it's so small now that for all intents and purposes, there's no latency. It's in
the nanoseconds in many. It's in the nanoseconds. If the traffic is enormously high, it could end up with being in the high, maybe a millisecond, maybe 1 millisecond or something like that, but it's not much.
So for all intents and purposes, it's non-existent.
Yeah, as far as the end user sees, as far as the end user is concerned,
Okay.
there is no latency. Because you can't tell anything, in a millisecond range. It's
Yeah,
not-
under what, like 100 milliseconds or 300 milliseconds? It's something like under that. You can't
Well,
actually sense
Yeah,
it.
movies, the reason that movies are at 30 frames a second is because you can't see the difference at 30 frames a second.
Oh, okay. Now, how has this impacted, obviously it's been a huge impact to the Internet of Things, but what are some of the practical, and this is for either one of you, what are some of the practical implications of the elimination of latency in terms of the Internet of Things?
Well, one potential is to get the improved data, improved data rates, so that basically you can do predictive analysis.
Okay.
And that predictive analysis is something that you couldn't do without LTE-5. Okay, it's just not feasible. But with extremely low latencies, you actually have the ability to do predictive analysis. And that's a game changer,
Okay.
So the short answer is that you end up closer to being able to make real-time decisions. That's the bottom line.
That's the key, is like real-time decisions in situations where it really matters, right? Like when you're driving and your car has to make an immediate decision based on the analysis of the inputs. And 5 years ago, there was not that sort of accuracy, right? We couldn't rely on data moving so quick that the driver could be completely out of the picture and the car could make a decision in literally a split second. And now without latency, you're not worried about, how quickly that decision can be made. So that's like a tangible example, right? Whenever you're dealing with large machinery that can be automated and has to do that analysis of input of complex, input, not just like one variable, you're looking at like complex objects of data that have to be analyzed and immediately made a decision spit out. Any situation like that, whether it's construction, whether it's you driving, whether it's planes, whatever the situation may be, if you can automate, we can definitely have a more realistic automation of those things now than ever before.
Now, go ahead.
Well, I think it comes down to feasibility. You're now entering a new level of feasibility that didn't exist before. And because that feasibility is there, you can now begin to do proof of concept things that you couldn't even think of before. And once you do these proof of concepts, then the next step is test to make sure they work. And then if everything is working as expected, then you can think about rolling them out into the world.
Now, let me ask you this, Alex, has this real time or the elimination of latency, what effect has that had on a blockchain, smart contracts? Obviously, AI has been a beneficiary. Talk about that a minute. What effect it's had on some of those things?
Well, they're kind of very different parts of the puzzle, right? Okay. Blockchain provides a really good way of managing these key value pair sets of data on distributed ledgers that are related to these decisions. And it allows for immediate settlement, right? It allows for immediate settlement of those decisions. And it doesn't require the centralization that would be actually an obstacle and a central point of vulnerability for very large distributed systems, right? But in that sense, they work together, but there's not necessarily a direct relationship.
Okay.
At least from my perspective, I don't know if, Jim, if you have another thought about it, but it's more about how they work together than it is of like what the direct impact on each other is.
Okay, I got you. Okay.
Well, I mean, think of it this way. You've got sensor input and you want that sensor input to go into a blockchain because it's immutable. You don't want it to be changed, And so you've got
permanent record.
You want a permanent record of it. And but the thing is that in the case of either the airplane or the E-plate, you may want others to know about it instantaneous, just as almost as instantaneously as you are gathering that information, because the guy is stopping in front of you. So, so latency becomes extremely significant, and processing time becomes extremely significant. So, but if you look at the Qualcomm, as I remember, it has 4 cores, and you want to make sure that you use all 4 of those cores and not let anything sit idle, because I wrote a lot of the I wrote some of the software in C#.NET, because I could utilize the parallel task library that C# has, and so I can spin off different tasks dynamically, and I can also use async and await, so that I can use async and await first if I want, just to make sure that I don't have a delay because I'm waiting for something, or I want to make absolutely sure that I'm using all 4 of the Snapdragon cores.
Yeah, on the front end, async await is super important on the front end too, because it allows that asynchronous communication with maybe a socket, right? We might have some sort of web socket. It's communicating, constantly. We're not dealing with waiting for long reloads.
Anything that downloads needs async and await.
Right. Yeah.
It has to have that. Otherwise, you're gonna lock something up for so many milliseconds that you don't want to do that.
And for people watching, the idea of asynchronous versus synchronous is essentially the idea of, am I holding everything up for one thing to happen, or am I allowing an asynchronous, multiple things to happen together, so that we're not just like stopped, right?
Yeah.
And so that's I guess it's a very simple way of describing. And so in terms of code, it's called async await, because we are deciding that this is some sort of asynchronous function, and we're awaiting in that asynchronous function for data. And there's sort of just terminology around what that process looks like, of getting data from a place and then doing something with that data.
Okay.
Yeah.
I just want to talk about this for a minute. I have a friend who's director of technology for a major corporation, and every time I see him, I say, "Okay, what's the latest? What's up?" And the last couple of times he said, autonomous vehicles, self-driving cars. He said, "Put your money on it." He said, "Find companies that do that, and that's where you put your money." Now, with the advent of the Internet of Things, say each car has an assigned identifier, that probably is going to be what may allow autonomous driving to happen. Would you agree with that?
I think, one of the things that I find super interesting that's happening with autonomous cars in particular, and the Internet of Things, is how modular things are starting to be. So, right now you have projects like Comma AI, for example, where you can actually turn your non-autonomous car, your normal car, into something that has some autonomous technology, right? The idea of like having modular pieces that are all connected and can communicate with each other through established protocols, I think is really interesting. The idea of integrating automation into things that otherwise didn't have it, and being able to make those decisions on your own to integrate it, to modularize your life a little bit, I think is a really cool power move as a user, rather than just being told my toaster oven is going to be smart and my salt shaker is going to be smart, my juicer is going to be smart, right? Things that people have pushed as projects that didn't make sense as smart devices, right? And like, how do I start automating my life without being pigeonholed into what a corporation has decided, right? I think that's definitely an interesting avenue.
Yeah, and you bring up a good point, because I think there are a lot of things that are so-called smart appliances that don't really do anything.
Like, what does it do? Like the juicer, they found that it was called the Juicero. This is so funny. It was called the Juicero, and it connected to the internet. You had like a subscription, and you would buy these juice bags, and essentially all it did was just squeeze the bag into a cup. So somebody actually showed that you could squeeze the bags quicker without using the machine. It was like a $400 smart juice machine that like did absolutely nothing. Like it literally just squeezed the bag.
Yeah,
And
yeah.
so, you know, we definitely see parts of this that become more hype and more rush to the, you know, it's a gold rush in some ways of like, how do we smartize our salt and pepper shaker?
I've been looking. We've been looking at refrigerators because we got to get a refrigerators pretty soon. I've been kind of putting it off, so I like to, do my due diligence. So, when I go into a couple stores, and they always take me to the smart refrigerators,
Mhm.
and I'm like, well, what the hell is a smart refrigerator?
Well, we're a smart refrigerator.
They
that
say
makes
if you leave the door open and let you know
sense.
if
Well-
the electricity is off, and let you know, which I guess could be useful information. But do I really need, an integrated circuit in my refrigerator?
You could, I mean, at some point it would, yeah, a refrigerator could actually make sense because it could keep inventory of what you have in the fridge. It
Yeah, it
could
does
be a
that
part
too,
of your
yeah.
shopping
Yeah,
list.
so, okay,
And then
okay.
it could start using that data to advertise to you. It knows what you have. It can keep track of expiration dates. So this is where I find it really interesting. Like sometimes I totally forget that something's expired. I don't know. I don't have like an inventory in my head or an Excel spreadsheet where I'm keeping
Mhm.
track of expiration dates of all the things in the fridge. You imagine if my fridge was keeping track of that for me, it shows me an alert like, hey, you need to get more ketchup. You need to throw this one out because it's 3 months out of date, right? Like
See, I didn't know
so
that.
there are scenarios where it makes sense.
Sure.
There's probably
Okay.
some things that are silly too, right? How do we start differentiating there?
Right. Okay.
Sounds like you're talking about adding a barcode reader so that basically every time you take something in or out of the refrigerator, it can scan that
Right.
and, and basically put that information in the cloud and say, I'll build you a shopping list and
Exactly.
I'll go. And then even better than that, when I build you your shopping list, I'll go take it out and take it to 6 different vendors and get a quote on the
Price shop. Automate it. You end up with, your Amazon Fresh delivery at your
Yeah, you
Yeah,
wouldn't even have to shop. It just sends you things when you needed them. So
right.
Yeah.
I can see where that's going. Yeah.
On the E-plate scenario, one of the markets that I looked at was the driverless truck market.
Mhm.
And it turns out that there are, in 2022, there will be 300,000 driverless trucks on the road.
Yeah. All these large companies are buying them.
Yeah, so there's, I mean, 2022 isn't that far off, and you're gonna have 300,000 large trucks on the road.
Mhm.
And my thinking is what does that do to the confidence level of the person driving next to this driverless car?
I saw a comedian who actually had a really good analogy. He said, a lot of people are scared of self-driving cars, but imagine when you go to the grocery store and there's those like automated doors, okay? And when's the last time you got hit by one, right? You haven't. So, but imagine like that times a million in your car versus the other option is imagine one guy who's high and one guy who's on his cell phone and they're manually opening and closing the doors for every person. Which one do you feel safer with? The one with sensors that knows exactly where you are, or the high dude and the dude distracted on his cell phone having to decide when to open the doors?
Yeah.
I trust the automation better, right? But the example is that's everybody else on the road. Some people are high, some people are on their cell phone. You should feel less safe in that scenario than letting a series of sensors and constantly learning software that doesn't have the human imperfections and the human distractions that we have, right?
Yeah.
So it's just different ways of thinking about it.
Well, getting back to the latency thing, if I'm driving near a huge driverless truck, that's pulling tandem things along with it, and the idiot light goes on the ECU. It says you've got a problem you know, and there's nobody there to respond, I'd really like to know about that, you know, and as soon as possible.
Right.
That is, I don't think that's far-fetched because, I mean, as we're all aware of, Google has, reported many deaths and accidents in their driverless cars.
Right.
So
I think the safest scenario is where more of the surrounding things are smart, right? So if you have a smarter set of cars on the road, vehicles, and you don't have a bunch of dumb people trying to respond to smart events, or smart events that are trying to respond to, you know, more dumb, unpredictable events. And then you imagine you might have smart roads, right? That are maybe communicating with those systems and know when something's gone awry and can divert traffic or prevent, you know what I mean? So you start thinking about how
it can maybe apply the brakes. It can apply the brakes and pull it off.
Right. You might have a safer system together rather than like one smart vehicle in a dumb world.
it's exactly where I'm going, is if you know about, if your vehicle knows about the problems of other vehicles that are huge, huge potential screw ups, okay, and because there are no, I mean, there are no perfect computer systems. I don't know of any. I've never worked on a perfect computer system. There's no such thing as a perfect piece of software, and sometimes it takes a significant amount of time for a software glitch to show up.
Mm-hmm.
You know, and only under the right system, right circumstances does it show up.
Yeah.
You know, if I'm driving next to a truck pulling huge machinery or something that's autonomous, geez, I'd like to know that it's okay to go buy this thing or do whatever I need to do to avoid a problem.
Right. Race conditions, right? In programming, we call them race conditions of like, what are those edge cases of a series of unpredictable events that create a very specific scenario that we couldn't have imagined in programming it, and the computer couldn't have imagined. And in that specific scenario, all hell breaks loose.
Well, C++ is one of the best examples of this, you know. C++ will let you do anything, you know, literally. And that can be because it could have a pointer that points off and hits an interrupt vector, and that interrupt vector is a reset.
Yeah. Well, JavaScript's a great example too, because it's half the things that you encounter on the web where you're just like, why is this not working? I'm clicking on this button, nothing's happening. I was expecting a modal. I was expecting this thing to happen. Half the time it's because JavaScript allows you to do whatever you want. And there's, you know.
And this is exactly why I'm making the directive to create any display in Dart and Flutter. Okay.
Instead of React Native.
I don't want anybody to write any JavaScript. Okay. Nobody.
Well, let me, I think
because Dart will, compile the JavaScript, and I trust that a hell of a lot more than somebody hand coding JavaScript. And you've experienced it.
Yeah.
So you would use a program to write your program. Is that what
absolutely. Use two things. Anything that you want, as a display system for Android, you would use Flutter as a framework. Mm-hmm. And then that's just a framework that says, hey, I know the set of API calls, I can do all kinds of fancy graphics or audio visual, whatever you want me to do, I'll do it. But Dart is Google's latest. It's been available for quite a while. Not a lot of people have migrated to it because they're still doing JavaScript by hand. But I think that's too problematic, and you want to have a program generate the program. Is exactly what you want to do. Because
mean,
it's
React Native is JavaScript, but if you use it with TypeScript, which strongly types it, then you're at least dealing with, it's still a program actually that ends up compiling to what's called native code. So essentially on the web now, a lot of people probably don't know this, but a lot of like what we do is it allows us to write really simple code when we're writing it, and then it compiles it into a lot more complicated things for actual use. So like when I write my code as a front engineer for the web, I'm writing it in really clean, separate files. I'm like, it's super organized. It's a lot of shared components, and it's very modular. And my job is a hell of a lot easier than it was 15 years ago, because then what these engines do is they compile it into much more redundant, complicated code that your browser like Google Chrome reads, or your phone, when you have a React Native app on your phone now has what's called a native app on it that's in whatever native code that is for the phone, depending on what type of phone it is. It's compiling into that, but you're writing it in really simple code. So our jobs have actually become a lot easier as engineers with these tools than when I first started.
Yeah. For sure. I agree. And one of the things that you want to consider is that you'd like to be able to do, the world runs around Android and iOS phones, period. There's nothing else really. So if you got those two covered, and Dart does have those two covered completely, then the next step is, well, you'd also like to write for Windows, Windows 10 at least, and maybe Windows 11.
Yeah.
And the way you do that is you can still reuse the code that you did for Android and iOS, and you can still have it run on Windows 10 or 11.
It's all about having reusable code, and that cuts down on errors, because if you're not having separate code bases for things, you're having one.
Yeah, and not only that, but because you're in a programming language like C++ has unit tests, so does C#, and also so does Dart. But I don't know of any unit tests for JavaScript that are worth anything.
Oh yeah, so for React testing library is very powerful. Enzyme, Chai, Mocha, Jest. So like there's tons of unit testing libraries for JavaScript that are really great now. And you write unit tests just like you would for any other language. You're like describing the test, you're writing what the test is, and you're including them, you're mocking certain things in order so that you can really isolate each specific thing you're testing. So that's definitely evolved pretty well too.
Well, you're ahead of me because I'd rather stick with a real language. A real language that is object-oriented, okay? And I can put my little object-oriented pieces together and let the compiler do it. Is that fair?
Yeah.
Okay, let's switch gears a little bit. One of the challenges that are facing the world now is hacking. Now, would it be possible to construct a language on the blockchain that's unhackable?
Well, the blockchain is immutable. You don't really have to worry about that.
Okay.
And it's verifiable.
Yeah, yeah, because everybody has the same copy of it. So, it's 100% verifiable. And the problem with hacking is that hacking is mostly. I'm going to go out on a limb here and say it's about 95% the user's fault. Okay.
Yeah.
If not more than that. Okay.
Okay.
Because they don't use multi-factor authentication. Big problem. You absolutely must use multi-factor.
Or they find a couple of new jump drives on the floor.
I was just getting to that.
USB cables now too.
USB cables. Okay.
I had an accountant, who was a wonderful CPA, call me up and say, Jim, I just got ransomware attacked. And I said, well, gee, that shouldn't be a problem. I mean, you should, you should be running your email system in Docker or, some other virtual.
Virtualization, yeah.
Yeah, you need a virtualization thing, and you put all your emails in the virtualization, and then you also run, in that virtualization, you run your best little virus thing in the virtualization. And if it finds anything, or you click on something you basically what happens is you click on an email that you're destroying yourself, and what you want is to do is just delete the entire virtualization.
Mhm.
You're done.
Clean slate,
done.
yeah.
You're done. And the virtualization, you don't want to network to your other PCs, by the way, not at all. Just keep it a standalone entity. So, and then I said, well, do you use Amazon S3 for backup? And she said, what's that?
Well, yeah. Well, yeah, most people don't know what virtualization is. They don't know what Amazon's any of the web services are in terms of where things are in the cloud. Most people
Explain those. Explain that. Explain.
So virtualization is the idea of like, I have some sort of virtual machine, right? So I can spin up an instance of a virtual machine. I'm using that virtual machine instead of the factory decided experience for my computer, right?
Mm-hmm.
This allows another layer, and if you set it up properly, maybe a few layers of protection between your underlying hardware and where the points of vulnerability are, right? It allows you to just like essentially wipe it clean and restart it. Create a new
virtualization. Yeah. Okay.
You can think of it as a sandbox, okay? A literal sandbox.
All right. Okay.
And you want to point your POP3 server, from the sandbox to the POP3 server, so that you download stuff, to the sandbox, and then have the emails and everything else that you download analyzed in that sandbox. And if anything goes wrong, you destroy the sandbox and create a new one.
Okay.
It's that simple.
Yeah.
So, I mean.
No. So why aren't companies doing this? Is it they don't want to spend the money, or is it a lack of knowledge, or
there is a learning curve, and it's a little bit cumbersome, right? Like it's not ridiculous. It's not that hard, but people are so used to not even turning their computer on and off, let alone wait, and so, I mean, we at like our company, we use YubiKeys, right? So like, this is my own YubiKey and it's part of our multi-factor authentication. I can't do anything unless I, use this to authenticate with my unique key on top of other, making sure that I use my cell phone. So my cell phone and this are required for pretty much everything I do. Okay. So, we don't always use virtualization, but in terms of our actual services and the code that we produce and all that's virtualized. Okay. I'm never doing anything in a vulnerable place. And I'm always making sure that I'm using multi-factor authentication so that it's not just one point of vulnerability, right? There's not just one layer that somebody else can get through. And that's where the problem you run into, where a lot of social engineering is being used, right? Because people think of hacking as like some guy in a movie with like 4 screens who's just like, opening up terminal windows and running scripts. And like sometimes hacking does involve running shell scripts. There's obviously code involved in many attacks still. But sometimes the scariest and simplest ones for companies that do have the layers of defense in terms of their technology, it's, somebody pretended to be a swag company, sent them free USB cables in a box as samples to give to all their top sales guys. And suddenly they had, they were costing the company $400 million because everybody plugged in their free USB cable charger into the computer. And the charger itself was,
someone sends you a digital wallet, a free digital wallet.
Don't use it whenever you get like free samples and you don't know, you can't verify where this free sample came from, or like you don't remember ever even asking for one, or
I wouldn't even use it now. Yeah.
Yeah, no, it's best to just like not use that, right? Like it's not worth, especially if you work in a high risk situation for a company and you have data that you wouldn't want getting, compromised. So
Because it could be something in the form of a Trojan horse that doesn't show up right away to be triggered at a later date. But that would be something that would show up in the sandbox, all right? You'd be able to tell in the sandbox.
well, if you have the proper monitoring set up,
Okay,
if you have the proper monitoring set up, if your
Even
IT
if it wasn't
department's
activated
monitoring,
yet, even if it
Yeah.
wasn't activated yet, it was still.
but sometimes the worst are ransomware, right? Like what happened to Jim's, your CPA said of like,
Yeah.
if ransomware shows up and your machine's locked until you pay them 3 Bitcoin or whatever, now you've got a problem, right? Because
Well, there's another issue here is that you should never have to pay ransomware if you're backed up properly, because I mean, sitting right here, okay, I'll show it to you. This has everything on the computer that I'm using right now, okay? I mean, and I think this is a $50 device, okay? And to me, it's worth spending $50 to put the operating system image on that drive.
Yeah.
Okay. Then in addition to that, you need to make a separate boot disk that goes to the CD-ROM. Okay. So now you can boot from the CD-ROM to this drive and restore everything, restore the operating system completely.
Yeah.
The next step is don't put any critical data on your computer, put it in the cloud and multi-factor password protected. So what you want to always be able to do is, if you get a ransomware, is delete everything on your computer, because all your data is in the cloud, backed up. And usually Amazon or Google or any of the big guys will have that backed up to 3 different locations. Okay. And they're not going to lose it. And I don't want to be responsible for running a Kubernetes farm. I don't want it.
So what would you do? Would you have an account with AWS? How would you be? Okay.
Yeah, well, even a Google account, even your Gmail account, is that you want a multi-factor. You always want a multi-factor access.
Authentication. Okay.
Yeah, Alex has both the cell phone and the PIN is required. Okay. Well, that's the way to go. And then nothing is on your computer that you can't restore from the cloud.
Right.
I mean, I use, for all software development, I've been using Visual Studio Team Services. Okay.
Say that again.
Visual Studio, I use Visual Studio Team Services. Okay. And so you're using Git, and
Git
using Git. And so Git is a distributed system, and you want to use Git in the cloud also. So basically, you can just do a Git to Git transfer. You can either push or you can clone from the cloud to your PC. So basically, what you want to, for anything you want to keep long term, I'll let Microsoft Azure take care of it.
Okay.
Let
me ask you this. Let me ask you this. Are VPNs overrated?
No.
Okay. All right. Okay.
But it's important.
Absolutely
It's
not.
important that you have VPNs in conjunction with these things, right?
Okay.
The problem with
Another layer. It's another.
Yeah.
That's another layer. Now
Another layer. Okay.
There's a new piece of hardware on the market that looks very, very intriguing. That I'm kind of want to get some more reviews on. But there's a new piece of hardware that basically has the potential to be a VPN all by itself. But so it's about a $400 box. That'll pay for itself really quickly. But I want to see more reviews more user reviews before I spend $400, on a replacement for my VPN.
They just call those VPN routers, right? Or they're like,
Yeah.
it's essentially the hardware that normally works without the VPN, but the VPN's baked into it.
Exactly.
Okay.
Exactly.
Now,
Well,
I have
yeah.
a very
Let me add
technical.
one thing. Well, let me
Okay,
add one thing here that's kind of. I have a government services guy that he's a Unix guru, and he works for the government. And what's really disturbing is that the government has too many routers that have the store-bought password. I mean, it's password or equivalent, it's password, the store-bought password.
Start.
and, and guess, nobody changes the password. Okay. And the government gets hacked. Okay.
Yeah.
And I'm going back to my initial statement, where I said 95% of this is your fault, if you get hacked. Well, if you don't change the password on a new router to something that's, I would make it at least 32 characters long, if not longer. Okay. At least 32 characters longer.
Okay.
But our government doesn't always see the light, or it's a little bit too little too late. A little too late.
Okay, I have a question. I want to get to. A gentleman from Seattle said, great information. He said, but tell me what the hell's going on with the crypto market?
I mean, well, we're seeing some consolidation, right? I mean, the market itself with crypto right now is consolidation. There's obviously the stuff with China. And actually the changes with China moving mining out of China has done great things for better distribution of mining. It's actually been a positive change. So, I don't want to talk specifically about price because ultimately, we know our opinions about price not being the sole goal of crypto.
In dollars, yeah.
But along the line of what we're talking about, if we bring it back to cryptocurrency, even cloud storage is moving towards decentralized models. You see things like the peer-to-peer IPFS, which is the interplanetary file system. You see decentralized projects that are blockchain based, like Storj, STORJ, Filecoin. You're seeing these migrations. We're essentially recreating our current infrastructure in decentralized models because it has great benefits in terms of security, in terms of ownership, in terms of efficiency. So there's a lot of changes happening there because we talk about security now, and a lot of these measures are required because of the vulnerability of centralized systems. And when you provide the security of blockchain, which like we established is not hackable, so it's not hackable by design. When you have the power of blockchain, and you combine that with the power of, the cloud and the power of having things where I could chuck my computer out the window tomorrow and destroy it, and I could start over, on my other laptop. Like that's the beauty of the what we've established.
Yeah.
But that's all been established because of these centralized companies like GitHub and like Google and like Amazon, right? That are profiting greatly off of the centralization of the web. And so when we look at a brighter future with decentralization, we look at that future where we can have true ownership over our data while still benefiting from that infrastructure that works.
Okay. All right. Well, we've about come to the end of this week's show. Jim, anything you want to say in closing?
Backup. Create many backups.
Okay, backup.
Create many backups. Use multi-factor authentication. and especially, um, it's very easy to back up the operating system image and create a boot disk, a CD-ROM boot disk.
All
You
right.
absolutely must do that. Otherwise, you will get hacked. And what you want to be able to do is just say, well, that's okay. All my data's in the cloud and I can restore my PC operating system in minutes. And that's the way you should go. And you never, ever pay ransomware. Ever.
Yeah,
Yeah.
don't ever pay. Yeah, never pay a ransom.
I mean, paying ransomware means you screwed up and didn't back everything up right. That's the bottom line.
And half the time you won't even get your data, so you end up paying and you don't get anything back.
Yeah, and you're not gonna.
There's no guarantee you'll get what you got.
The chances of them giving you the key to decrypt your hard drive are nil, none, and
When
extreme.
you look at the code, most of them don't even have that. There's not even functionality.
Yeah, it's yeah. So it's your fault. I mean, I hate to make this analogy, but if you don't get vaccinated, if you don't vaccinate your computer or you don't vaccinate yourself, you're in trouble.
Yeah, that's right. Yeah, you're on your own. Yeah. Okay. Good words of wisdom. Alex, any closing thoughts?
Yeah, I think, what's cool is that we really dove into some existing technology and we looked at how this technology is evolving on its own. And I think what we were able to do here is look at really tangible examples of how decentralization and blockchain, not as a technology just by itself, but as a technology in conjunction with these things, is going to make things better, right? It's going to make driving safer and better. It's going to make, how you back things up, how you store things better. It's going to make, work together with new Wi-Fi protocols and new wireless protocols with less latency. It's going to work with all of these things for a really cool future and a really safer future for everybody. So yeah, I think that was, we really covered a wider spectrum that allows people to see how is this useful beyond just getting rich quick, or, you know what I mean? Like, what are some of the tangible benefits of this technology?
And usually how you get rich is you come up with a useful idea.
Right.
A million people can use, Go ahead, Jim.
Some of the other possibilities of this blockchain thing are, that really make sense are title control, where instead of making a mess of paper, all the titles belong on blockchain.
Yeah.
Right.
Registrations belong on blockchain. All of that information needs to shift over to blockchain, and then it becomes so much easier to manage that whole system. And the cost savings, as I pointed out in the document I sent you this afternoon, are enormous. I mean, just the savings of getting rid of the title work and the registration thing would pay for itself over and over again. And then once you have that, you can think about going to companies like Root. Root was started in Ohio. It's an insurance company that's trying to get into the real-time insurance, and that's somebody that I want to deal with, because once you're in this domain, then you can think about having insurance per trip, okay, rather than an annual fee. I have a winter beater. It sits there all the time. I don't want to insure it, okay, for 6 months.
Okay.
So basically, I would use a company like Root, ROOT, to real-time insure my vehicle when I drive it.
And when you need it. Okay. Well, great. We want to thank you, Jim, for coming on the show, and I'm sure this won't be your last time, because you're my neighbor, and I know I'll run into you. So you won't be able to hide from us. So I'll see you.
Do we get a rating from the crowd here at all, or?
Yeah, we will. We usually get a lot of feedback. People can reach us on the DeFi Collective at gmail.com. And we're on YouTube under Let's Talk Radio, the DeFi Collective. So if you didn't address your questions on Facebook, please, you can reach us at the DeFi Collective at gmail.com, and we will respond back to you because we do our shows based on what people want to hear and what people want to talk about. So we really encourage you to, let us know. The DeFi Collective at Gmail, pretty simple. We thank you for your time, and unfortunately ours is up, but until next week, have a great day, stay safe. And I can't say wear your mask because you don't have to wear it some places. Now, but just use your own good judgment when it comes to that.
Yep.
All right. Have a good day.
Have a good one.
Thanks.